Good morning. We were discussing about the importance of the insulation coordination for the electrical equipment which are used in the transmission and distribution systems. Further, we were also discussing about the ceramic or porcelain and glass insulators for their service performance. Now, we will discuss about the non-ceramic or the composite insulators which are of recent origin and are being used from the distribution class to the very high voltage levels up to the ultra high voltage levels. So, these silicon rubber or polymeric or composite insulators are being manufactured from for different voltage levels and are being used for railway traction, transmission and also for distribution purposes. So, we have briefly looked into the composition, the metal fixtures and the manufacturing of the porcelain polymeric insulators. There are some issues as earlier discussed. Initially this polymer or composite insulators were of concern. Later on the technology has improved and still it needs to be improved, particularly in the maintenance aspects for the hotline maintenance of the insulators, and there are groups which are being working towards this improvmental aspects and also trying to come up with the newer maintenance procedures for the EHV and UHV class, which they do not exist presently. So, polymer or composite insulators have some better advantages in compared to the porcelain or glass. We will look into the advantages of these insulators. So, polymeric or composite insulators offer better contamination flashover performance than porcelain insulators. This is one of the important property where the utilities are much more comfortable in using this insulator during the polluted or the contaminated conditions and the zones where regular contamination or a pollution flashover do occur. So, apart from that, the polymer insulators have a smaller core in comparison and weather shed diameters. So, the petticoats or the shed dimensions of the porcelain or ceramic or glass are much bigger in size, bulky in size. So, here the material is organic as mentioned, they are lighter in weight and also the shed diameter is comparatively lesser to the porcelain or the glass insulator. This increases the leakage current density. So, higher leakage current density means more ohmic heating. So, this is one of the advantages. So, this ohmic heating helps to dry the contaminated layer and reduce the leakage currents. The reason is once the contamination or the polluted layer on the which is formed on the insulator surface becomes wet, the conduction happens, the surface gets conducted and the leakage current flows. Because of the heating which is happening, lesser surface area when compared to the ceramic, here the heating is more. This helps to dry the contaminated surface. Further, once the surface dries, then the leakage current, the dry band or the formation of the dry area offers a very high resistance and further that reduces the leakage current flow. So, this is one of the major advantages because of the hydrophobic in nature, where the water repelling property of the polymer insulator has an advantage in compared to the earlier ceramic or porcelain insulators. In addition, hydrophobicity helps in minimizing the filming. So, there is a property which repels the water droplets to form on the insulator surface. So, once this happens, So, there is no water filming on the surface, then minimizing the water filming also reduces the leakage current. So, the conduction is reduced. So, this is the important property of the polymer or a composite insulators. As mentioned, contamination performance of the composite insulator exceeds that of the porcelain. This is what it has been noticed in the field, the literature, and also field conditions reports that the performance particularly for the contamination or pollution, polymeric insulators offer better performance in comparison to the earlier ceramic or porcelain insulators. So, contamination performance of silicon or a composite is also exceeds the EPDM units, which were earlier version of the silicon rubber. So, much better in case of pollution or contamination. This phenomena is very important because as we discussed, pollution or contamination is a very serious threat above extra high voltage, that is 400 kilovolts and above. Contamination plays a major role in the line design of EHV system. So, the property of the composite insulators offer better performance during the contamination or pollution is a major advantage in comparison to other type of insulating materials. So, there are few disadvantages because of the reports or the service performance where the data has been available. This majorly for the first generation or the second generation polymer insulators. Further lot of improvements have been taken in this regard. So, the disadvantages could be to carefully look into the maintenance and also the manufacturing aspects, procedures or the manufacturing protocols which are being followed to be carefully looked into. In case the moisture or water, in case there is a damage to the insulating rubber on the surface of a polymeric insulator, there could be a water entering into the core, fiberglass core. This could lead to failure. There are reports which failures have happened because of the moisture entering and the formation of nitric acid, and this nitric acid causing the brittle fracture to the fiberglass rod. Further, improper crimping, particularly this has to be carefully looked into when the fiberglass rod is being crimped at the edges by the mechanical metallic clamps or the end fittings. So, this end fittings proper crimping arrangement has to be done with a specified procedure and also the specified hydraulic pressure of this to be taken into consideration. The reason is during crimping even a minor crack formation or the overload because of the procedure which is being done could later on cause the insulator to shatter, where this micro cracks may lead to the failure of the insulator or the fiberglass rod, and the line could be thrown away. So, this is a very important factor particularly during the manufacturing stage where it has to be taken into consideration. And third limitation is because as mentioned the insulators, polymer insulators being organic in nature, they are sensitive to environment. So, environment plays a very important role for the overhead transmission system. So, the line where it is passing and the climatic conditions of that area where the tower is situated, insulators are placed. So, this environment is playing a role. We will further look into the various environmental parameters which could cause a serious issues to the insulators in service. So, with service experience over 3 decades since the initial composite insulators were used for the transmission systems, now in several countries it is being widely used even for the EHV and UHV range. So, there are some experiences with the polymers over a period of time. So, initially there were few there initially there were failures noticed because of several issues. So, like surface degradation of the polymer surface, the surface gets degraded. This reason could be because of the ultraviolet radiations from the sun over a period of time. The UV radiations from the corona control rings which are fixed on either side of the metallic fittings near the insulators. So, this if it is not properly placed or the corona control rings are not properly designed, this could cause the discharges, this corona discharges continuously hitting the surface on the insulator over a period of time could cause the damage to the insulator surface, and this damage because of the moisture, because of the pollution, because of the fog or snow entering into the surface could cause the nitric acid. Here again the failures have reported over a period of time. Similarly, electrical stress, because the insulators are continuously in electrical stress. So, these are prone for tracking and traying. So, where in case the surface becomes hard or stiff, brittle in nature, over a period of time the hydrophobicity property which we were discussing, this hydrophobicity property could be reduced over a period because of the continuous hardening of the silicon rubber, and this leads to the higher leakage currents leading to the arcing. Arcing could be in case of the surface arcing what we call scintillations or a partial arcs. This could be again due to the formation of the dry band and wet band on the surface, because the surface may not be continuously wet or partially wet. So, these small bands which become due to rain or because of the fog conditions, the surface which becomes partially wet and partially dry results in the arcing known as the partial arcs or scintillations. This results depending upon the surface conditions, the surface resistance offered. So, this dry band wet band formation followed by the leakage current depending upon the surface conditions could lead to flashover, and sometimes mechanical failure also because of the fiberglass rod failures. So, there could also be a mechanical failure where the line could get detached. Some reports have indicated the mechanical failures because of the degradation. So, similarly internal degradation, this could happen because of the cracked rod, as I mentioned in the manufacturing stage or during the stringing there could be internal damage. This cracked rod, because of the end fittings with the pressure microstructure, there could be micro cracks which could have happened, and this could develop over a period of time, or this could be because of the coating between the rod and sheath before the silicon rubber material is molded on the fiberglass rod. So, the bad coating also could cause the internal degradation over a period of time, or the voids, small air pockets between the rod and sheath over a period of time could again lead to the air pockets getting discharged, the charge build up, and also the failure happens because of the insulation becoming weak at that junctions, where this small air pockets could break down, and the water entering into these places further could in case if there is a microstructure damage to the fiberglass rod, the acid which is formed could contribute to the failure of the internal degradation between the rod and the sheath. So, this could again result in the flashovers, line lockouts or blackouts, partial blackouts what we call, and also apart from this it could also cause the worker safety concerns as the problems for carrying out live line maintenance are not fully developed, it is being developed for this insulators. So, this internal degradation could also cause a serious concerns to the safety aspects and also the utility engineers for the maintenance. The important part as mentioned earlier and discussed earlier, the contamination or the pollution performance of these insulators in the field is a very important factor for the design consideration. I am mentioning several times. So, the contamination performance dictates the insulator particularly at higher EHV and UHV ultra high voltage range. So, this we will be discussing in detail about the phenomena of the contamination, the pollution, how the failure happens at the normal conditions, and what could be the reasons for the failures at the working stresses. During the climatic conditions or due to the area where the insulators are being used, continuous fog or continuous mist which is on the insulators, there are reports about the mold growth over a period of time, particularly in cold places or cold countries or the places where the temperature is much below where these lines are being operated. So, there are contamination due to mold growth also. And as mentioned above, the brittle fracture, again I am stressing this. This happens again combination of the reasons like where the fiberglass rod, it could be because of the crimping issue during the manufacturing stage or during the operation where the corona control rings are not properly designed or not properly placed. The discharges which are coming out from the corona control rings continuously hitting the surface of the polymer insulator, further beginning the insulation. In case of the damage to the surface of the insulator, the water or the moisture or the fog entering this junction over a period of this, because of the corona, continuous corona, there could be formation of the nitric acid. This nitric acid again interaction with the rod could also both mechanically and electrically, the stress could see that there are failures reported for the brittleness or a brittle fracture what it is known. So, this has to be properly taken care and the maintenance has to be looked into for the fiberglass rod not to see that insulation on the surface gets eroded. This gives the main information about how various stresses whatever we have discussed in detail about the polymer insulators or a composite insulators being degraded, how the failure could happen. So, you can see that the various stresses which are shown, these stresses could be because of the environmental issues or could be the electrical stresses. So, environmental issues as discussed, environmental stresses could be because of the temperature where the climatic conditions of that area where the transmission system is in place. It could be of various temperatures the insulators have to perform during the temperature. Ultraviolet, again as mentioned, ultraviolet could be from the rays, ultraviolet radiations from the sun. In case of very high temperature, the sun radiations could make the insulator surface brittle over a period of time, or the ultraviolet radiations which are being generated because of the corona control rings improper design or the placement of the corona control rings are not proper position, or during the over a period of time due to the wind or due to the mechanical issues, the corona control rings could have been shifted. So, this again causes the placement of the corona control rings, could cause in case of the surface of the corona control ring could create a continuous corona on the surface where UV from the corona also could be generated and it could degrade the surface. Similarly, there are instances where the acid could be acid rain which particular areas face about this acidic components from the rain where it on the insulator surface could create a hardness, And apart from that, there are several industries which could be of chemical or which could be of other insulators, where acidic components which are being sprayed on the surface over a period of time could cause the degradation in the long run. Then other environmental factor being the wind. Again, wind brings in lot of dust, lot of pollutants to the surface. So, over the period of time this settle and this pollution or the contamination builds up the surface in case there are some damages. So, this pollutants may enter into the surface and slowly the degradation could happen. So, wind again it depends whether the insulator string is in the which part of the then if it is because of the sand, even the sand sometimes contains very high salts. These salts again are sprayed on the surface and could damage. Then rain also will aid in the flashover of the insulators. It could again cause the surface to become wet. If it is heavy rain, there is it is a complicating factor where the sheds could be breached. That is a reason where the alternate sheds are being designed as mentioned earlier. So, rain again could make the surface wet, conduct, and the flashover could happen. Similarly, snow, fog, mist are more serious as this settle over the surface the contaminants which are already existing over a period, and this during this monsoon season, if the rain, snow or mist or fog could cause the surface becomes wet, making the surface conduct and higher leakage currents, and depending upon the surface conditions the formation of the dry bands and wet bands because of this uneven spread of contaminants. So, here again the surface could degrade because of the conditions. So, apart from these conditions, there is also reports like biological degradation as mentioned earlier. This could be because of the mold growth in colder countries or places where continuous temperature is very low, and mist or continuous places where receives lot of rain. Here the mold growth over a period of time could cause the degradation on the surface. So, the consequence of these environmental stresses, various environmental stresses, it could be the temperature, either heat or very low temperature also will have a issue problems of environmental stresses. Ultraviolet radiations could be from again the sun or from the ultraviolet radiation generated from the corona of the hardware or corona control rings of the insulator string. Conductors, it should give because of the acid rain composition, or it could be because of the industries which are nearby to the transmission system. So, these stresses could cause the depolymerization. There could be a chain scission, breakage of the bonding on the of the material, and oxidation could happen. So, this depolymerization what we call further could lead to loss of elasticity, that is the rubber property of the rubber could become brittle or it could become stiff. This could again lead to the mechanical property where mechanical issues, where the decrease in the strength of the mechanical aspects. So, further erosion or roughness. So, roughness again of the material or material peeling off from the surface because of the continuous discharges or damages, and the chalking or cracking because of the stiffness. This could lead to the decrease in electrical strength because the creepage which is being designed could come down because of these issues, where the surface resistance offered is very low and the material is damaged. So, could cause the electrical insulating strength or decrease in electrical strength. So, further these are the environmental issues. So, pertaining to the electrical stresses. So, electrical stresses as mentioned, we have arcing again on the surface because of the formation of the dry or wet bands. This as mentioned over a period of time or during the monsoon conditions or during the early morning conditions where the fog or mist is on the is subjected on the insulator surfaces, snows, mist, this along with the pollutants, contaminants starts conducting the surface because of the non-uniformity of this coating or the pollutants collected, and also due to the wind conditions, the surface becomes conducting in some portion and some portion does not conduct. So, where this dry band or wet band formations happen on the surface, and small arcings or partial arcs do happen, and sometimes because of the corona as mentioned, the hardware which is being used, it could be from the conductors, it could be because of the insulator corona control rings which fix to the insulator, or the clamps or the metallic end fittings which are fixed to the insulator. These generate corona if it is not properly designed or properly placed. Further thing the surface conducts and the leakage current flow. So, this continuous leakage current flow could heat up the surface, and the degradation of the surface could happen, where loss of low molecular weight components could be observed over a period of time. And further to this phenomena, over a period there could be loss of hydrophobicity. So, as mentioned, loss of hydrophobicity again in case the water repelling property of the polymer or a composite insulator is lost. So, further the pollutants or the surface conditions due to wetting because of fog or snow would slowly try to see that the entire surface gets conducted, or the volume of the insulator surface gets conducting, and the degradation happens and the entire insulator starts conducting, and a flashover could also happen. So, these are some of the electrical effects which could happen over a period of time. Here further this will definitely decrease the electrical strength. So, you see the electrical stresses, various stresses, environmental electrical stresses here, and what are the effects from these things are given here, the effects, and the final result. When you see the final result, it could be the decrease or the insulation strength coming down, and the flashover could happen, or if the mechanically it could become unstable, where the insulator string can because of brittle fracture or because of the rubber becoming it could peel off from the insulator surface. So, these are very important regular maintenance or regular requires these are concerns particularly, and requires lot of maintenance for the polymeric or composite insulators. Some of the failures which have happened from the literature has been presented here. These are not the present available information. This could be over a period of time since the inception of this technology. So, there are several failures or the problems which are being reported here. Could be a tracking, you can see here the tracking of the insulator over a period of time. This could be because of the continuous surface degradation where the electric arc or the current starts conducting and the flashover happening over the surface. So, this leads to the failure of the entire string, and the replacement is the second being the erosion. You can see the material peeling off over a period of time. This could happen because of several reasons as mentioned. It could be the environmental issues, it could be continuous failures because of the material becoming harder, the entire material has been peeled. So, this surface erosion could happen because of the reasons where brings down the entire creepage distance and the flashover happens. Then effect of weathering conditions, again weathering conditions could be because of the sun, because of the ultraviolet radiations, or because of the exposure to corona control things over a period of time. You can see the surface becoming stiffness, becoming brittle, and the entire surface becoming hydrophilic, where it will be able to conduct and the failure happens. This gives the effect of corona over a period of time. You can see the metallic junction to the fiberglass rod. So, this is a very critical thing where it has to be taken care. Once there are microstructure damages as mentioned, the water or a moisture or the mist fog seeping in could lead to the brittle fracture. The corrosion happening near the metal end fittings is not a healthy thing. So, it has to be properly seen that coatings of the metallic end fittings are done and it is being properly protected. Similarly, as discussed, effect of acid rain. Acid rain or the acidic components which are spread from the factories nearby to the transmission system could again lead to the surface degradation over a period, and this could damage the insulator in the field. There are several again failures which were reported earlier. It could be because of the hydrophobicity loss, accumulation of dust, accumulation of the dirt, mold, or because of it becomes dirt over a period of time. Similarly, you have a loss of hydrophobicity, the sheds being mechanically weaker, where the this shows again the hydrophilic nature where the water droplet starts accumulating over the surface. So, these type of failures were noticed earlier in the stages. Now, lot of technology improvements have happened in the material aspects and also the manufacturing processes. So, here you see the corrosion of the end fittings. This could lead to the failures of the post insulators or the suspension type of insulators. Similarly, the debonding of the sheds. So, this again if it is not properly taken care during the manufacturing period, this debonding of the sheds could lead to the failures over a period of time. So, special care has to be taken into considerations. There are failures in some of the countries where due to the gunshots, where the failures have happened to the fiberglass rod, or the post insulators where it is damaged by the bullets which are spread. Similarly, as mentioned earlier, you can see the small air pockets which are during the manufacturing period. So, this if it is left unnoticed because of the electrical stress, because of the environmental aspects, these air pockets may damage or may break, and this further leads to the water seepage or the moisture seepage inside could lead to the failure. So, care has to be taken to see that no air pockets or blowhole air bubbles present on the surface of the insulator. Similarly, here there is a fiberglass rod exposure because of over a period of time the peeling of the material has taken place in both the cases here. So, this exposed due to the continuous stress or tracking or damage to the insulator surface. There are further reports about the hardware damages. You can see here the corona control ring or the end fitting which is fixed to the insulator surface degraded over a period and becomes highly corrosive, and this leads to the failure of the insulators over a period of time. You can see again these failures of the corona ring due to the lightning surges or over a period of time in the service, and where failures have been noticed. Again here it is a tracking or a surface erosion which has happened in both the cases. This could result in the failure of the rod exposure. There are again failures due to several of these aspects because of the birds or because of the animals which have to be properly considered or taken care during the transportation or storage. So, here the insulators, as you see many of the insulator surfaces are being chipped off either by birds or by the rodents. This would cause the entire creepage to come down and the flashover, or you cannot use the insulators for the stringing. So, careful not only the manufacturing, storage, transportation are also equal, and protecting from the birds, large birds, animals is also causing concern to the utilities. So, birds like to chip the surface of the insulator, but this could bring down the creepage and ultimate failures over a period of time. Similarly, bird droppings, this is again a very serious issue. Bird droppings on the insulator surface over a period of time, this is again a conductive fluid on the surface where the insulator starts conducting, and the failure have been noticed because of bird droppings over a period of time, or the bird droppings with the combination of the fog or mist could make the surface conductive, degrade over the surface. So, several of these issues are also of serious concern to the utilities in proper functioning of the transmission network. There are some failures even in the country which are reported. This could again I would like to explain for the EHV insulators where the failures have happened at various junctions. You can see one of the failure is because of the brittle fracture happened after the 5th or 4th shed here, it has happened in the country. Similarly, you can see the failure happened at the 3rd insulator, this is a polymeric insulator where it has happened after the 3rd insulator. So, there are failures which have happened immediately after the stringing within a year or so. This again is a very serious concern. This was evaluated, and this reason was due to the placement of the corona control ring. The placement and the design of the corona control ring, as I mentioned earlier, is very important. The corona discharges from the corona control rings over a period of time continuously, which are impinging on the surface. So, this corona control ring causes the corona particularly at any instant, and during foul weather conditions this could aggravate, and where this entire insulation portion could damage the surface. And as I mentioned, in case the fiberglass rod during the mechanical fixing of this end fittings, if the micro structural damages are there, this water seepage or the radiations because of this UV continuous corona could lead to the degradation and where the line get detached. So, these are some of the practical failures which have been noticed in the field. Now, coming to the comparison of the features of insulators, there is a comparison of all the 3 technologies, the non-ceramic or the polymeric insulator, the porcelain, the glass, and also the resistive glazed coating of the ceramic or a porcelain insulators. So, these 4 when you compare you see the positive and both the negative advantages. So, in the positive we have better weight reduction, that is you can see around, depending upon the voltage level, the insulator string reduction comes down to 90%. This is a very important factor for the utility people to work. So, the lightweight it is very easy to string and advantageous. So, similarly there are advantages working with the pollution or a contaminated conditions. So, the polymer insulators have better attributes in comparison to the ceramic or the other profile. And as mentioned, the low cost, now the cost of the composite insulators is much compared lower than any ceramic or glass type of insulators. And the profile, the smaller profile comparison, and it is aesthetic in comparison to the other technology. So, now some negative attributes, reduced strike distance, but this is again taken into consideration in the newer technologies. These are susceptible to aging. So, as I told, because of organic in nature, the polymer or a composite insulators are susceptible to aging, degradation, surface becoming brittle, surface becoming stiff, hydrophobicity loss, there could be a fracture, material becoming brittle fracture over a period of time. So, several of these attributes, a lot of effort has been made to see the material improvement aspect is being done. And as the technology is of not very old, so limited experience particularly in handling, storing and transportation, Apart from this, live line techniques have to be developed, particularly for extra high voltage and ultra high voltage ranges. So, where like ceramic or porcelain insulators, the technology for live line washing or live line maintenance, the tools, the procedures have to be still developed. So, this is one of the important aspects where people are trying to focus on this. The porcelain or a ceramic, this performance has been quantified, long history of use, more than 100 years. The negative being the weight, yes, comparison to the technology of polymer, the weight is higher. Then pin corrosion failures are observed. There are failures because of the post cascade failures, some hidden defects as mentioned because of the ceramic insulators, particularly the pin junction, because of the crack formation or the cement growth. There are failures which could not be which cannot be observed by the naked eye. And here again places where vandalism, both ceramic and glass insulators are furnished, there are failures or vandalism failures, and lot of maintenance cost is being to be considered at that places. So, similarly there are improved version of the resistive glaze, the resistive glaze coating on the porcelain, they have also tried out, particularly for the contaminated or the pollution conditions. These have better performances when compared to the normal porcelain or the ceramic insulators. But the question is price for the coating and how long the coating does exist, and the loss of power because of the surface conditions. So, several of these factors again make to think for the utilities to go in for this type of technology. The glass as like a ceramic or a porcelain, it is better in comparison to see that spotted damages units could be easily known because of the transparent in nature. Again it is similar to the ceramic or porcelain, where the weight is one of the important criteria. As the voltage level increases, the number of insulator increases, the weight also increases. The stringing is a concern, particularly at high altitude and mountainous areas. Both porcelain and glass insulator stringing is a very difficult task. So, these in particular areas are attractive to vandal. So, stone throwing and the gunshots could damage the bells of the insulators and bring down the surface creepage of the string and failures. So, these are some of the comparison of features of various technologies which are being adopted. So, I put this slide, it is just to compare how people like to work in the area with the polymer insulators. You can see the ceramic and the polymer insulators. So, the weight reduction is one of the important criteria where people like to work in this area, whereas stringing is very difficult in case of a porcelain or the glass type of insulators. So, looks more aesthetic in comparison, and lesser weight, and the maintenance could be of less when comparison to the ceramic or the porcelain glass insulators. So, with this we will end the class. I will be discussing about the pollution or a contamination effect, as I told you, which is a serious threat to the transmission insulators in the next class. So, thank you.